Hello, today is December 5th, so I want to talk about something to do with 5. I want to talk about pentaquarks. These are one of my favourite particles, really. The idea is it's 3 quarks, as you normally find in a baryon, and then a quark-antiquark pair. Together that makes 5 sort of quarks and antiquarks in a group. These were predicted back in 1987, and the masses were predicted, and experiments looked for them and they didn't really find them. And then in the early 2000s, a few experiments started to see some kind of evidence. They were looking in their mass spectra and they were finding a peak. These were mainly fixed target experiments. One experiment saw a few sigma, and then another one would come along and see a few sigma, and they keep accumulating more and more evidence for these pentaquarks. And this would be a brand new kind of baryon. This would be a fantastic discovery. And none of the experiments got to the 5 sigma level needed to declare a discovery, but when you combine them you got far more than 5 sigma. It was extremely exciting, and so other experiments started to look. My own experiment, Barbar, started to look for them. Bell started to look, and they didn't see any evidence. These were E plus E minus colliders, so the electrons and positrons came in. They would produce all kinds of particles, and part of that would be pentaquarks. And some of the experiments actually steered their beams to hit fixed targets and to look for them. And they didn't find them in these experiments. Now, the interesting thing is that after a while, the experiments that did claim to see them went and looked with more data, and the effects seemed to go away. It was a really peculiar thing, because they seemed to have a very statistically significant peak across many experiments. And after a while it just seemed to go away, and this is what the particle data group actually said about it. There has not been a high statistics confirmation of any of the original experiments that claim to see the theta plus, this is the pentaquark. There have been 2 high statistics repeats from Jefferson Lab which have clearly shown the original positive claims in those 2 cases to be wrong. There have been a number of other high statistics experiments, none of which have found any evidence for the theta plus, and all attempts to confirm the other 2 claimed pentaquark states have led to negative results. The conclusion that pentaquarks in general, and the theta plus in particular, do not exist appears compelling. Wow. They went even further in 2008. They actually had a section dedicated to pentaquark searches in the Review on Particle Physics, and in 2008 they updated it. It said, there were over 2 or 3 recent experiments that found weak evidence for signals near the nominal masses, but there is simply no point in tabulating them in view of the overwhelming evidence that the claimed pentaquarks do not exist. The whole story, the discoveries themselves, the tidal wave of papers by theorists and phenomenologists that followed, and the eventual undiscovery, is a curious episode in the history of science, especially given the definitive results by Fred in 1971. So, basically, a lot of experiments thought they saw something. They see a distribution like this, a huge peak, and then it would fall off. They seem to corroborate each other's results, and then when they got more statistics, it went away. Now, this is of course one of the reasons why we require 5 sigma before we say we discovered something new. And there have been a few papers put out to give a kind of kinematic argument why you'd actually see a peak like this. If you actually have a beam coming in, you have angular dependent effects which give you different masses, and you can actually shape those masses with different selections, and that can give you a peak. So it's been a very interesting episode, and also another very amusing one. It's one that really makes you think about where we get biases from in our experiments, from our psyche basically. When one group sees something and another group somewhere else sees something similar, we sort of build up each other's confidence, and we've got to be very careful of these things. And like the particle data group says, it's a curious episode that we need to know about, and it's something that just remains very interesting and curious, and something that I find is quite amusing. Okay, I'll see you tomorrow.